Now let us start with rules for drawing ray diagrams for convex mirror. As we can see, we have a convex mirror here which is curved outwards. In the previous video, we have looked at images formed by concave mirror which is curved inwards. Now you can see here that the focus and the center of curvature of the mirror are behind the mirror. As a result, rays of light which are incoming from the left side of the mirror cannot directly pass through the focus or cannot directly pass through center of curvature. So for these cases, we will have the rays directed towards the focus or directed towards the center of curvature, or emerging or appearing to be emerging from the focus or emerging from the center of curvature. So let us start with the first rule. As we did in the case for concave mirror, the first ray will be parallel to the principal axis. Principal axis is the line passing through pole of the mirror and center of curvature. So the ray of light incident is parallel to the principal axis. Now for concave mirror, because the focus was in front of the mirror, after reflection it could pass through that focus, but that is not possible in this case. So in this scenario, the ray of light gets reflected such that it appears to have emerged from the focus. So it appears to have emerged from the focus. We will use dash line to denote it is not a real ray, it is appearing to be emerging from that, and then it gets reflected. So after reflection, it appears to have emerged from the focus, but actually it is not emerging from focus. It cannot pass through this point because this is behind the mirror. So this is rule 1. Rule 1 is incident ray parallel to the principal axis after reflection appears to have emerged from the focus. We denote it by showing dotted line behind the mirror. Now for rule 2, the incident ray for concave mirror was passing through focus, as we cannot have that in this example because focus is behind the mirror. We will have incident ray directed towards the focus. So to show that incident ray is directed towards the focus, incident ray directed towards the focus. Now after reflection, it will go parallel to the principal axis. So incident ray is directed towards the focus. After reflection, it will go parallel to the principal axis. This is rule 2. Incident ray directed towards the focus after reflection goes parallel to the principal axis. For the third rule, in concave mirror, we had incident ray passing through center of curvature. After reflection, it retraces the same path. Here also we will have a similar ray, but instead of passing through center of curvature, the incident ray will be directed towards the center of curvature. So let us draw a ray which is directed towards the center of curvature. Show it with dotted line because it is behind the mirror. So the incident ray is directed towards the center of curvature. Because center of curvature is behind the mirror, the ray cannot actually pass through it. After reflection, it will retrace its path. So after reflection, it will come back. So this is will be the incident ray. After reflection, it will retrace the path back. So this is rule 3. Incident ray directed towards the center of curvature after reflection retraces its path. So these are the rays which we will use to draw ray diagrams for an object placed in front of a convex mirror. When we looked at images formed by a concave mirror, because we had focus, center of curvature, both these points in front of the mirror, we had 6 different scenarios: object between pole and focus, object at focus, object between center of curvature and focus, object at center of curvature, object beyond center of curvature, and object at very large distance, that is infinite distance. But because both focus and center of curvature are behind the mirror, we cannot keep an object at various positions. So we have only 2 cases here. First case will be object placed directly in front of the mirror, that is at a finite distance in front of the mirror, and the second case will be object kept at infinite distance in front of mirror, that is a very large distance. So first case, object is kept in front of the mirror and at a finite distance. So let us consider this object kept in front of a convex mirror. Now let us draw ray diagrams using the rules which we have just looked at. So the first rule is ray of light passing, or rather parallel to the principal axis after reflection, appears to be emerging from the focus. So let us consider this incident ray parallel to the principal axis. After reflection, it will appear to have emerged from the focus. Because we have to show emerging from the focus, we will use dotted lines behind the mirror and complete lines in front of the mirror. So this incident ray after reflection appears to have emerged from the focus. Now the second rule will be incident ray directed towards focus goes parallel to the principal axis. So let us draw a ray which is directed towards focus. So behind the mirror we will use a dotted line. So this is the incident ray. After reflection, it will go parallel to the principal axis. So after reflection, it goes parallel to the principal axis. So let us extend this behind the mirror. Because we are behind the mirror, we will use a dotted lines, and we can clearly see a point of intersection here. So that will be the image of the top of the object. So let that be A dash. Let us draw the image. Object will be named AB. Image will be A dash B dash mirror MN. We can clearly see that image is formed behind the mirror, and visibly image is smaller than the object. Object is much larger. Object is larger than the image. So let us write the properties. So object is in front of the mirror Object is in front of the mirror. Image, we can clearly see that image is between pole and focus. So image is between pole and focus of the mirror. Now, what is the nature? We can see that image is upright. So we call such image erect image, and because it is formed behind the mirror, it is virtual. That is, it cannot be obtained on a screen. So nature is erect and virtual. And what can we say about its size? It is clearly visible that object is larger than the image. So we call such images which are smaller than the objects diminished. So image is diminished. Image is diminished. So object in front of the mirror, image between pole and focus of the mirror, nature will be erect and virtual, size will be diminished. Now on to second and final case for image formation in case of convex mirrors. Object will be kept at infinity, that is a very large distance. So object is kept at a very large distance. So all the incident rays will be parallel to the principal axis. Now we have studied first rule. If incident ray is parallel to the principal axis, then reflected ray appears to have emerged from the focus. So all the reflected rays will have appeared to be emerging from the focus. So let us see. So this is the incident ray. Let us slightly extend it. Because it is coming from infinity, let us use dotted line. Similarly, we will have an incident ray coming from bottom of the object. After reflection, they will have emerged from the focus. So after reflection, they emerge from the focus. So where will the image form? Image will form at the focus. Dotted line behind the mirror. So this will be the image. This is the object AB at a very large distance, that is infinite distance from the mirror. Let us name the mirror MN. So we can clearly see object of finite size has formed point sized image. So object, if it is at a very large distance in front of a convex mirror, it forms a point image at the focus, that is behind the mirror. Images behind the mirror are called virtual images, and virtual images are always upright or erect. So let us write the details. Object at a very large, that is infinite distance, image at the principal focus, nature Because image is behind the mirror, it is virtual, and virtual images are always erect. So erect and virtual. And what about the size? Size will be point image. So when object was placed at a very large distance in front of a concave mirror, it formed image also at the focus, which was point image, but that image was real and inverted. In case of convex mirror, the image formed is virtual and erect. Also point image also at the principal focus, but for convex mirror, the image will be erect and virtual. Now, in both the scenarios, image formed by convex mirror is always virtual. So, we can say that convex mirror always forms virtual images.